Hi everyone! In this video, I'm going to walk you through how to create a project in SamRoot, explore the Root Simulator, and show you the 3 coding levels students can use to program their virtual or physical Root robot. To begin, look on the left-hand side in Sam Studio and click on Create SamRoot. This takes you to the SamRoot home screen where students can create new projects, explore the Getting Started with Root Robot, or try the built-in Level 1 coding challenges. For today, we're going to begin by clicking on the Add button. When the project opens, the layout is divided into 2 main parts. On the right side, you'll see your Root Simulator, a virtual Root robot that students can use even without the physical device. On the left-hand side here, you will see the coding workspace where students can drag and drop and build their code. At the top of the screen, you'll see a play button to test their system, as well as a stop to pause it. Students can also zoom in or zoom out to give themselves more room when building larger systems. We also recommend naming the project after the lesson or activity you're doing. This helps keep your workspace organized and models best practices for students. Along the bottom of your screen here, you will see the 3 different coding levels for students to choose from. The first level here is our graphical coding, level 1. It's perfect for beginners. Students can drag and drop the different icons in as the code begins and reads from left to right, just like creating a sentence. Each block is color coordinated. The blue blocks are events, yellow are commands, green are setters, and light blue are flow controls like repeat, wait, or other conditions. Level 2 uses block-based coding. Here, students can begin seeing words and categories, including math, logic, and variables. This level allows for more advanced systems like drawing using coordinates, creating games, or programming animations and interactive challenges. Level 3 then is Python coding. This is where students can drag and drop text boxes to format, and that introduces real programming syntax while still preventing common beginner errors. Students can move between the 3 levels to grow confidence in, so I can easily click back to level 2 or even level 1. If a student wishes to get rid of something in the code that they built, they can simply drag and drop it down into the garbage can here that will get rid of it. They can even delete an entire row if they wish. To begin coding, drag puzzle pieces or blocks into the workspace. Again, you can use the zoom in or zoom out. You can also press play to see the virtual Root robot respond inside the simulator for what you have built. Here I have the when pressed play, I want my Root robot to start. Let's test our system. And here I can see the Root is moving with what my system says on the left-hand side. The simulator isn't just a blank grid. Students can even explore fun extras in here. Students can zoom in or zoom out as well. If they zoom out enough, they can also see some virtual tools, such as stickers they can use and blocks and shapes. Students can place these objects on the grid and program the Root to interact with them. For example, maybe if I place this sticker here, I can program my Root to move to land on that sticker. If I have different blocks that are on my grid, I can program the Root to move around the blocks or follow paths or collect even virtual objects. Built right into the platform too are some level 1 coding challenges where you and your students can get some practice using some of these tools. You'll see this later on in our challenges today in your training. Now I'd like us to try something simple together. I'm going to place a few stickers on my grid. I'm going to use the rocket ship here. and then I'm going to use the star. I'm going to place these stickers on the grid, and now we're going to program our virtual root robot to move to each sticker using level 1 code here. This is a great way to help students practice sequencing movement and problem solving while having fun inside the simulator. Here I see that my rocket ship is 2 spaces moving forwards. Right now I have only 1, so I need to drag and drop 1 more of my root blocks here to move my root forward. Let's test our system. I did it. I was able to program my root moving forward. Now if I move the root back, I want it to turn and then land on the star. So I need to look at my blocks here to help me determine which way I want to move my root robot. Again, this is a great strategy you can do with your students. Even those that can't read yet can see which way some of these blocks are moving. In this case, I want my root to move to the right, so I'm going to drag and drop my turn right block here. You saw when I clicked on the block as well, it tells me what the block does, which is a great feature. Once I have it turn, I then need to have it move 2 spaces forwards. Let's test our system. I see it moving to the right, and now it has moved up 2 spaces. That's how you create a project in SamRoot, explore the simulator, and use the 3 different coding levels. You saw I did all of this without even having to attach my physical root robot. This is great for you and your students to begin using the platform. If you have any additional questions about the root robot, you can continue watching in these videos or reach out to your customer success representative. Whether your students have physical root robots or not, the simulator gives them a powerful place to learn, test, and create.